Hi friends, we're going to talk today about the concept of points to double odds, which is in short called as PDO, uh, points to double odds, which is quite relevant to building of scorecards. These scorecards are typically used in measuring credit risk. Now, some of you might be aware that while you make scorecards, what you try to do is fit some sort of a simple logistic regression equation which models log odds, something like this log of p by 1 minus p, where p is the probability of default as a function of alpha plus x beta, where alpha and beta are the parameters you fit the model for, and x is the independent variables, and p is the probability of default that you're trying to model. Now, obviously, building this model is a separate ball game, but what we are going to discuss today is uh, how do you make this measure, which is log odds, uh, more interpretable in a real life context. Because log of odds is a particularly strange number, which might be difficult to interpret for non-quantitative users. So people in the credit risk department who will be using such a model to assess obligors need to have some sort of a simple scale or simple number that they can visualize when they're thinking of taking a lending decision. Um, Therefore, what is typically done is this output from the model is converted into a score, and the score is transformed in a way that it has an intuitive relationship with the odds. So, effectively, what we try to do is we try to say that at a particular score S, we want the odds to be 1:1, which means the odds of being in default and not in default are equal. And in addition, we add one more condition that we would like if the score changes from S1 to S2, and in case the odds are doubling between the two scores. So if the odds at this were O1 and the odds at S2 are twice O1, then we would like the difference between S1 and S2 to be 20 points, i.e., we want S2 to be equal to S1 plus 20. So just think of it. One can easily kind of then in use one can if you have a way to transform the odds into this framework, you can say that a score of S. Uh, the moment I look at the score of S and not the log value, I can easily say that yes, this client has an equal probability of being in default and non-default. While if I look at a score of S plus 20, then I know uh, that this is more likely to be a good client than a bad client. So these are the, let's say, expectations or requirements, and the concept of PDO is what helps us reach there. So, in very simple terms, how do we get from this to this score? So first, we start with a simple example to gain an intuition on how this kind of transformation works. So let's take an example where your log of odds is 50 is to 1, and for another client it's 100 is to 1. So this is the probability of being good, and this one is probability of being bad. You want the difference between the two to be 20 points. So if you take the difference, this will be log of 50 minus log of 100, which is equal to log of 50 by 100, which is equal to minus times log of 100 by 50 is equal to minus log 2. Or in other words, you can say log of 100 minus log of 50 is equal to log 2. Now what I said is these are the logouts and the difference is log 2 for any two numbers which are in the multiplication. So 50 times 2 is 100. You take any two numbers, you'll always get log 2. But what I would like in this scale is for this difference to be a specific number of points, which is 20 in this case. So if I want to transform this log 2 into 20, what I need to do is I need to multiply this by 20 and divide by log 2. And this gives me 20. So this number that we use to multiply the difference in the log odds here is called the factor. So what this basically tells me is that if I take the log odds, let's say log odds 100, multiply it by this factor minus log odds of another number which is half of it times the factor again, I'll get 20. Why? Because I take a factor common, log of 100 by 50 is equal to factor times log 2. And the way my factor is defined is 20 times log 2 times log 2. So these two cancel out and you're left with 20. So if you assign or if you multiply these log odds by this factor, which is this number 20 by log 2, the difference between these two becomes 20. So that's one part of the story. So this is how you achieve this 20-point difference is you multiply the log odds from the model by a factor which is equal to 20 points divided by log 2. Now the next part is how do you set a particular score or a baseline score which translate into 1:1 probability or odds. Okay, so what we are interested in doing now is that we're interested in translating or setting a base score, which is S for us, as a certain specific value where the odds of being good or bad are equally likely. So, for example, if the probability of default is 50%, I would say 50% being good and 50% being bad, then the odds are 1:1. So how do we set the score? That is simple. I mean, using the same formula, what we say is I want the log of 1:1 or log of 1 basically to be equivalent to a particular score. And let's call this as S. So because log of odds, uh, when log is when the odds are equally likely is 0, so log of 1 is 0 because e raised to 0 is equal to 1. So log of 1 equal to 0. Uh, if I need this value to be equivalent to a particular score, I just need to add a s to this term as a transformation. So effectively, there are two steps to be done. First, on the log of odds, you multiply those with a factor. This allows you to get the 20 points for doubling of the score. And secondly, you need to add a score S that allows you to set the base score. Uh, the log of odds here we have defined as probability of being in good versus bad. Uh, in some or in most models, uh, the when the PD is being modeled, the model output is actually log of bad by good, which is log of PD by 1 minus PD, or what we called in the previous slide is log of P by 1 minus P. So to invert this into this fashion, what we have to do is we have to multiply this with a -1. So -1 times log of bad by good will be equal to log of good by bad through simple logarithmic calculations. So effectively, this can be rewritten as -1 times log of bad by good, which is the model output, times the factor plus a base score S. So this is how you would go from log of odds, which is a model output, to a score which is meeting these two criteria that we discussed in the prior slide, that any difference between two scores where the odds are doubling is 20 points, and When the odds are equal, you set a baseline score as S. So in most, we're going to look at an example as well. In most cases, uh, what one of the parameters that is commonly used is for equal odds of 1:1. The base score that is set is 600. So for this, S becomes 600, and through the transformation of the multiplication of the factor of 20 by log 2, what you achieve is this. So once the log when the odds moves from 1 to 2, you will see the score moves from 600 to 620. If it moves from 2 to 4, which is further doubling, it moves from 620 to 640. So once a user is using your model, a PD model, he sees a score of one client as 600 and 620 as another client. He would clearly know that the odds of this customer B is twice that of odds of customer A. And odds in this context, as we said, a higher score is a lower probability of default. So this means that this has higher chances of being a better customer versus this, and the odds are roughly twice. So that was all for a short introduction on points to double odds. Hope to see you in the next session. Thank you.